Hello, so in today's lesson I wanted to go over how to solve systems of inequalities. So with systems of inequalities, unlike systems of equations, we have only one method of solving them. And I guess depending on which method you liked for solving systems of equations, that could either be good news or bad news. Personally, I think it's good news. So the only way to solve a system of inequalities is by graphing them. So I just want to run through a couple of quick examples on how we solve these, and hopefully that will enlighten you guys. So in solving system of equalities, we're kind of combining what we know about graphing single inequalities as well as what we learned about systems of equations. So let's see, suppose we have y is less than 3, and say y is greater than or equal to 2/3 x minus 2. So if we suppose these were just equations, if we wanted to solve a system of equations graphically, we would graph each of these equations and find the point where they cross. So we were kind of applying what we knew about graphing equations and just graphing two of them. So with inequalities, we're kind of going to use the same process. So first, let's graph y is less than or equal to 3. So we're going to go up 3. So we're going to be right here. And since y is less than 3, we're just going to have a horizontal line. We're going to make sure that it's a dotted line, because this is less than and not less than or equal to. So our line is going to look something like this. I guess exactly like this. So there's our line. And since y is less than 3, I'm going to shade in below the line. So I'm going to use these diagonal blue shadings to represent the solutions to this equation. So now we have another line to graph. We have y is greater than or equal to 2/3 x minus 2. So our y-intercept is negative 2. Our slope is 2/3, which slope is rise over run. So that means that we go right 3 units and up 2. 1, 2, 3, 1, 2. And then we would just connect the dots, and we'd get something along the lines of that. And since y is greater than or equal to 2/3 x minus 2, we're going to shade the area above the line. So I'm going to shade in black to represent the solution to this inequality. So the solution to our inequality is going to be the area that is shaded by both inequalities. So we have a lot of colors on here. It might be a little bit hard to see, but the solution to this system of inequalities is going to be this triangular plane area right here. So I'll just outline it again, and it's going to look something like that. So in your work, as long as you represent the solution area, the area that satisfies both inequalities clearly on your graph, that's an acceptable answer. So you could use different color highlighters if you happen to have them. If you have a pencil, you could just shade in the area that satisfies both inequalities, or you could kind of do what I did, and you could shade using crosshairs one way for one inequality and crosshairs going the other way for the other inequality, and the solution area would be the area in which both areas are shaded, so you get the crosses. So there is no way to solve a system of inequalities graphically. No way to solve a system of inequalities algebraically. Sorry. So this is our only way of solving one, and this beautiful picture over here is considered a perfectly valid solution. So now let's dig a little bit deeper. Let's check and see if our answers make sense. So what our graph tells us is anything that's shaded from both inequalities is going to be a solution. So we can pick a really easy point. Let's pick the point 0, 0. So the point 0, 0 is shaded by both inequalities. So if we plug 0, 0 into equation number 1, we get 0 is less than 3, which is true. If we plug it into the second one, we get 0 is greater than or equal to 2/3 times 0 minus 2, which is also true. And as we know, if a point satisfies both inequalities, then it's a solution, so that makes sense. Now let's pick a point that might be shaded by one but not both inequalities. So let's pick the point, let's see, let's do 3, -1. So if we pick the point 3, -1, so our y value is -1, so -1 is less than 3, so we're good on that count. For our second equation, we have y is equal to -1, which is greater than or equal to 2/3 times 3 minus 2. If we simplify that, we get -1 is greater than or equal to 2 minus 2. And we get -1 is greater than or equal to 0. And that is not true. 0 is greater than -1. So that makes sense since this point is not shaded in this inequality. So since this point satisfies one but not both inequalities, it is not a solution. Whereas this equation was a solution. Draw a little smiley face because that makes us happy. So now let's just run through one more quick example. So why don't we do y is less than or equal to -1/2 x plus 4. Let's do y is less than let's see, 5x minus 1. So let's do our first equation first. So we get y is less than or equal to -1/2 x plus 4. So we're going to find the y-intercept. Our slope is -1/2, so that means we go down 1 and right 2. And our equation is going to look something like that. And since y is less than or equal to that, we're going to shade the area below the curve. So also note that since this is less than or equal to, that's why I have a solid line here. So just be careful because that can get a little bit tricky to remember sometimes. So our second equation is y is less than 5x minus 1. So our y-intercept is -1. Our slope is 5, so that means we go up 5 and over 1. So 1, 2, 3, 4, 5 over 1. Do the same thing. And then here, do the same thing. We would connect this line so that it looks like this. Although, I made a mistake, so y is less than and not less than or equal to, so we have to make this a dotted line. Luckily, I caught my mistake before too long. So now, since y is less than, we would shade the side under the curve. So I would shade the area that looks like that. So again, the solution to this system of inequalities is going to be the area that is shaded by both inequalities. So it's going to be this area right here. So this is the solution to this system of inequalities, again, because it's shaded by both. So hopefully this is a pretty good lesson on how to solve systems of inequalities. I'd be happy to go over more examples during class, or answer any questions you may have on this video.